Hello everyone, I welcome you all in this exciting video. We are looking at a question from the Science 2025 GCE, which is paper 2, and this is in section C, question number 3B. So the question went like this: butyl propanoate is an ester. Name two reagents used to form it. Okay, so we have a term here that I want us to understand: an ester. Okay, so an ester, these are among the compounds that we found. Okay, we have about 5 homologous series. We have alkanes, alkenes, alkanols, and then we have carboxylic acids, then we have esters. Okay, so now esters are formed between, what I want us to understand is what an ester is. Okay, so it's not really a good idea to just memorize definitions. Okay, so first of all, before we answer this question, let us understand what is an ester. Okay, so an ester is a substance. Okay, it's an organic compound that is formed. Okay, an organic compound that is formed when you react an alcohol. Okay, an alcohol plus a carboxylic acid. So you're supposed to react an alcohol plus a carboxylic acid. And then after that, what you're going to get, okay, you get an ester, but there's another substance that is given out, which is, let's write H2O. So when you react an alcohol and a carboxylic acid, you are going to get an ester and then alcohol. So this type of reaction, we call them condensation reaction. Okay, because there's a loss of a water molecule. Okay, so this compound that we have, butyl propanoate, okay, butyl propanoate is an ester. And how this ester was formed, there was a reaction between an alcohol, organic alcohol, plus a carboxylic acid, and this is what gave us this ester. So they want us to find the two reagents, and this is very easy. Name two reagents used to form it. Okay, this is very, very easy. So we have the name here. Okay, I want us to understand. We have the name butyl. So the name is butyl propanoate. Okay, butyl propanoate. So we know that in this there was an alcohol and an acid. Okay, so now there is this thing that used to help me in secondary school, NODAC. Okay, and what this simply means, N simply means name, D simply means what? Draw. Okay, OL is the last name from the alcohol, so it means name the alcohol first, then draw the acid first. Okay, so when you are naming, okay, like here, this is a name. So the name, it says alcohol should be first. Okay, so name alcohol first. So it means the first name here was the alcohol, meaning this came from the acid. Okay, remember, no dark. So how does the dark come in? Draw. So when you're drawing the structure, then you don't start with the alcohol. You see the structure, you start with an acid. So here it says draw acid first. Okay, OL means alcohol. Let me just write it. And AC means acid. So when giving it the name, the ester's name, you start with an alcohol. So it means the first part was an alcohol. Okay, was an alcohol, and the second part was what? An acid. Okay, the second part was an acid. So always remember and have this in mind. And I'm going to show you the structure for butyl propanoate. You see how you can apply this butyl propanoate properly. Okay, so let's name the two reagents first. Okay, so we've already known that the butyl was coming from the alcohol, and what alcohol has the name but? It's butanol. So it was butanol. Propanoate, which acid starts with the prefix prop? Propanoic acid. So that's all. The two reagents were what? Butanol and propanoic acid. So nice and easy. Okay, it was just butanol and propanoic acid. Okay, let's illustrate this. Let us illustrate this. We know what we want now. It's butanol as well as propanoic acid. Okay, so if you react butanol, okay, plus propanoic acid, this will give us the ester, which is butyl propanoate plus water. Okay, now I'm going to show the structures for these. If you haven't watched my previous video, I taught on how you can draw structures. Just go scroll down under organic chemistry. There's video 1, 2, and 3. So butanol, remember this prefix simply means 4 carbon atoms. So I'm going to show 4 carbon atoms. The OL meaning there is an hydroxyl group. Okay, so this is the structure for butanol. Nice and easy. Okay, sometimes you can use the molecular formula, but I just like to make things easier. Okay, then plus, what is this now? This is an acid, prop meaning 3, just 3. Okay, okay, this is the acidic group. Okay, so this is propanoic acid. So again, if you're not sure how to draw these, just watch my previous videos. Okay, so this is butanol and this is propanoic acid. Now remember, I said from NODAC, when drawing now, we are not going to start with the alcohol because we say no, this is butyl propanoid. You're going to make an error. So you start with this, but first let's explain what is going to happen. It's a condensation reaction. It needs to remove water. Okay, it needs to remove water. So what happens is this: there should be water that is going to be given out. There should be water that is going to be given out. So this OH, okay, will react with one H from the acid. So look at what do you have here. So when these two react together, they will definitely form water. So is what we mean when we say condensation reaction. So in drawing, remember here we've removed the H. So in drawing, I'm going to start with my acid. I want to draw the ester now. Look at how I'm going to do it. Okay, so I have 1, 2, 3, and then with the O that remained, and then the other O here. Okay, so I'm just removing the H from this sign. Okay, so everything here I'm maintaining it. So I do this. Okay, then now this is the acid. Remember, draw the acid first. So I've drawn the acid. Then I'm going to connect this acid now to this C. Okay, so I'll bring, how many C's are here? I'll write 4. 1, 2, 3, 4. So the last one, which is here, okay, the last one which is here, it has got 3 carbon, hydrogen, just like this. Let's see, this one doesn't have, let's see, okay, I didn't just put here, needed to have this sign. Okay, yeah, so here, this is actually the structure of butyl propanoate. Okay, this is the structure for butyl propanoate, and then you show at the end that there was a water molecule that was given out. Now, there is something really interesting about this structure here, because of the link here, the part where the alcohol joined to the carboxylic acid. So we have a link here, and this link, which is this, okay, this link, we call it the ester. We call it the ester linkage. Okay, we call it the ester linkage. So when naming, we started with the alcohol, but when drawing, start with the acid. You are going to get a perfect ester linkage. Okay. So here the question just wanted us to name the 2 reagents, which we have given the names, butanol and propanoic acid. Okay. So this was question C1A that we've answered. Okay. Now we are going to answer the other remaining questions on this. So question C2 says, describe a chemical test for the minor byproduct of esterification. This was quite a confusing question, actually, if you don't understand. So first, they're talking about esterification, and we said esterification, you react an alcohol plus a carboxylic acid. What do you get? An ester plus what? Water. Okay. Now, the question says, describe a chemical test for the minor byproduct. So there are 2 products here that are given in esterification, ester and water. So the minor byproduct is water. Okay, water is the minor byproduct. It's just given, fine. The main product here is the ester. So now, what's the chemical test for water? How can you test for water? How can you tell that this is water? Just a simple chemical test we use in the laboratory. Okay, so we're going to say use anhydrous copper 2 sulfate. This one is white in color. Okay, but in contact in water, okay, we can say water changes the color to light blue. It's just say, yeah, it changes. So this is the chemical test for the minor byproduct. So the key that, I'm sure they wanted to confuse you by using minor. What is a minor byproduct? I'm sure maybe a lot were confused here. But they are just asking what's the chemical test, the identity test for water. So you get anhydrous copper 2 sulfate, which is initially white. Once it comes in contact with water, because now it's going to have water of crystallization, and then it's going to turn it to what? To blue. Okay. Let's go to question D. Question D says state 2 uses of esters. D2 give one similarity between esterification and the neutralization. So two uses of esters. Okay, two uses of esters. You are going to say esters. They have a sweet smelling. Um, they are sweet smelling substances, eh? So they would be uh, used in making perfumes, okay, sprays, okay, fragrances, perfume, sprays, body mist, whatever. Okay, then two, another use. Sorry, they have also a sweet taste. Okay, you can mix different types of esters to get uh, flavorings. Okay, food flavorings, and some of them can be used making apple juice, banana, and they smell just like the actual fruit. Okay, so that these are the uses. Then D2, similarity between esterification and sterilization. Now the difference, okay, is only that in the products, sorry, in the okay, let me show them. You see, let's start with neutralization. Neutralization is a reaction between a base plus an acid, while esterification is a reaction between an alcohol plus an acid, carboxylic acid. So they have this in common. This one will give you salt plus water. This one will give you ester plus water. So just look at the similarity here and here. Okay, so depending on how you want to write that, okay, but that is the similarity. Both produce water at the end. Both reaction involve reacting something this with an acid. Okay, so this was 2025 GCE question C3B. Okay, if you have any questions, please leave them in the comment section. For tuitions, just reach out on the number on the channel. See you in my next video.